speaker of Greenland and I am going to explain working model of earthquake. This model is made by biodegradable materials like cardboard and watercolors. In this I have used one motor, two batteries, two connectors and one switch. This is my model. Earthquake is mainly because of the movement of tectonic plates. This mainly happens because of irregularities or fault zones present in the lower zones of Earth. These vibrations travel to the surface of the Earth as seismic waves and felt as earthquake. In this model, I am showing how the earthquake is seen when it happens and how it causes damage to property and life. Me and my teammates are going to explain about earthquake in detail and its information by using PPT. My teammates are Anirudh, Om, Hasini, Vignajit, Manela, Nishant and Utpala.
What is an earthquake? Earthquakes are shaking, rolling, or sudden shock on the surface of the earth. They are Earth's natural means of releasing stress. They can be felt over a large area even though they last barely a minute. Earthquakes cannot be predicted. Earthquakes. When they when the break line between the two rocks suddenly moves, the movement causes vibration or the seismic waves to rapidly outward in all directions from the focus. The point at ground level directly move above the focus is called epicenter.
Why do earthquakes occur? They may occur because of fractures or faults. Energy is released and it propagates in all directions as seismic waves, thus causing earthquake.
Longitudinal wave, P waves, also sound waves, transverse wave, S waves, also light waves.
How do earthquakes occur naturally? Tectonic earthquakes occur anywhere in the earth where there is sufficient stored elastic strain energy to drive fracture propagation along a fault plane. The sides of a fault move past each other smoothly and aseismically only if there are no irregularities or asperities along the fault surface that increase the frictional resistance. What are the different types of faults that cause earthquake? There are three main types of faults, all of which may cause an interplate earthquake: normal, reverse, and strike slip. Normal and reverse faulting are examples of dip slip where the displacement along the fault is in the direction of dip and where movement on them involves a vertical component. Normal faults occur mainly in areas where the crust is being extended, such as a divergent boundary. Reverse faults occur in areas where the crust is being shortened, such as at a convergent boundary. Strike slip faults are steep structures where the two sides of fault slip horizontally past each other. Transfer boundaries are a particular type of strike slip fault. Many earthquakes are caused by the movement on faults that have components of both dip slip and strike slip. This is known as oblique slip. Now, information about the earthquakes that occur away from the plate boundaries. Where plate boundaries occur within the continental lithosphere, deformation is spread out over a much larger area than the plate boundary itself. In the case of the San Andreas Fault continental transform, Many earthquakes occur away from the plate boundary and are related to the strains developed within the broader zone of deformation caused by major irregularities in the fault trace. The North Ridge earthquake was associated with movement on a blind thrust within such a zone. Another example is strongly oblique convergent plate boundary between the Arabian and Eurasian plates. It runs through the northwestern part of Zagros Mountain. The deformation associated with this plate boundary is partitioned into nearly pure thrust sense movements perpendicular to boundary over a wide zone to the southwest and nearly pure strike slip motion along the main recent fault close to the actual plate boundary itself. It is demonstrated by earthquake focal mechanisms.
Two ways to measure an earthquake size. Magnitude, Richter scale, measures the energy released by fault movement related to the maximum amplitude of this wave measured from the seismogram. Logarithmic scale, quantitative measure. For each whole number, there is a 31.5 MES increase in energy. Example, an increase from 5 to 7 on the Richter scale, an increase in energy of 992 times. Measuring earthquakes. Seismometers, instruments that detect seismic waves. Seismographs, record intensity, height, and amplitude of seismic waves. Intensity, Mercalli scale. What did you feel? Assigns an intensity or rating to measure an earthquake at a particular location. Qualitative. 1 to 12 buildings nearly destroyed. Measures the destructive effect. Intensity is a function of energy released by fault, geology of the location, surface substrate can magnify shock waves, example Mexico City 1985 and San Francisco 1989.
Measuring and locating earthquake in center scale used to discover a scale of an earthquake beginning with the Richard Malley scale in 1930. It is released in simplest and of an A used because in 21st century segment was traveling through earth earth eccentric and can be recorded by sun in at great distance. The surface wave was developed in 1950 as it is mean to Armenian report earthquake and improves the aims further large events. The momentum Matthian scale not only measures in the shock but also takes amount of several movements. The Japan Machinery Agency in Trajan scale, thus the Maldives Stromboli scale, are based on the different effects and not only released by of shaking. Every time project differently in surface wave which is traveled through rock within different velocity. Lofty pre-wave shock and pressure waves traveling as wave both body waves, surface wave. Earthquakes and volcanic actions. Earthquakes often occur in volcanic regions and they are caused due to the burst by tectonic functions and the movement of magma in volcano. Such a volcanoes can suffer a very warming and volcanic eruption as during in 1980 eruption of Mount Saint Helens. Earthquake swarms can serve as market of locating and floating magma through the volcano. The slaves can be recorded by seismometers or tin measures, a device which measures ground slope and used as tectonic to prevent the upcoming eruptions.
Effects of earthquakes. The effects of earthquakes includes but are not limited to the following: shaking and ground rupture, soil liquefaction, human impacts, landslides, fires, tsunami, floods.
Disadvantages of earthquakes. Earthquakes can be very dangerous. If you're in the wrong place, they can make buildings fall down and set off landslides, as well as having many other deadly effects. An earthquake that occurs at the bottom of the sea can push water upwards and create massive waves called tsunami. Prediction. Earthquake prediction is a branch of the science of seismology concerned with the specification of time, location, and magnitude of future earthquakes within stated limits. Many methods have been developed for predicting the time and place in which earthquakes will occur. Despite considerable research efforts by seismologists, scientifically reproducible predictions cannot yet be made specific to a specific day or
Yes,
month.
the objective of earthquake engineering is to foresee the impact of earthquakes on buildings and other structures and to design such structures to minimize the risk of damage. Existing structures can be modified by seismic retrofitting to improve their resistance to earthquake. Earthquake insurance can provide building owners with financial protection against losses resulting from earthquakes. Emergency management strategies can be employed by the government or organization to mitigate risks and prepare for consequences. Artificial intelligence may help to access buildings and plan precautionary operations. The IGOR expert system is a part of mobile laboratory that supports the procedures leading to the seismic assessment of masonry buildings and planning retrofitting operations on them. It has been successfully applied to access buildings in Lisbon, Rhodes, and Naples. Individuals can also take preparedness steps like securing water heaters and heavy items that could injure someone, locating shutoffs for utilities, and being educated about what to do when shaking starts. For areas near large bodies of water, earthquake preparedness encompasses the possibility of a tsunami caused by a large quake. Precautions for earthquake. During an earthquake, keep calm and reassure others. During the event, the safest place is an open space, away from buildings. If you are indoors, take cover under a desk, table, bed, or doorways and against inside walls and staircase. Stay away from glass doors, glass panes, windows, and outside doors. Recent earthquake has many effects like ground shaking, surface faulting, ground failure, and tsunami. Tsunami. Earthquakes occurring below the ocean causes tsunami. Ground rupture. Ground rupture is another important effect of earthquake movement along a fault actually breaks the earth's surface. Ground shaking. Ground shaking is a result of passage of seismic waves through the ground and ranges from quite gentle in small earthquake to incredibly violent large earthquakes. A series of vibration induced in the Earth's crust by the upright and the rebound of rocks in which elastic strain has been slowly accumulating is called earthquake. There are four types of earthquake: tectonic, volcanic, collapse, and explosion.
Precautions to be taken during an earthquake. Keep calm and rescue others. During the event, the safest place is an open space away from buildings. If you are indoors, take cover under a desk, table, bed, or doorways and against inside walls and staircase. Stay away from glass doors, glass panes, windows, or outside doors. Do not rush to go out of the building. If you are outside, move away from buildings and UTP wires. Once in the open, stay there till the vibration stops. If you are in a moving vehicle, stop as quickly as possible and stay in the vehicle. Free all pets and domestic animals so that they can run outside. Do not use candles, matches, or other open flames. Put out all the fires.
The major earthquake that happened in India, Koch, Gujarat. The 2001 Gujarat earthquake, also known as the Bhuj earthquake, occurred on 26th January, India's 52nd Republic Day, at 8:46 a.m. IST. The epicenter was about 9 kilometers southwest of the village of Chobari in Baju Taluka of Kutch district of Gujarat, India. Tectonic setting. Gujarat lies 300 to 400 kilometers from the plate boundary between the Indian plate and the Eurasian plate, but the current tectonics is still governed by the effects of the continuing continental collision along this boundary. During the breakup of Gondwana in the Jurassic period, this area was affected by rifting with a roughly west east trend. FX. The death toll in the Koch region was 12,300. Bhuj, which was suited only 20 kilometers away from the epicenter, was devastated. Considerable damage also occurred in Baju and Anja, with hundreds of villages flattened in Taluka of Anjar, Bhuj, and Baju. Over the million structures were damaged or destroyed, including many historic buildings and tourist attractions. City planning. The Environmental Planning Collaborative EPC was commissioned to provide a new city for the city